Okay, so now we start with example 1. Okay, so in example 1 you need to refer to the question I did post in Moodle. Okay, so refer to question past year questions semester 2 2010-2011. Okay, so in the question it gave you the IR filter function, okay, which is HZ. Okay, so you have HZ, so HZ equal to 0.39. So if you look at this transfer function, you know that, okay, the upper part is your numerator part, your below part is your denominator part. Alright, so again, if you remember your lecture, in my previous lecture I did mention that this, for denominator part, the first constant must always equals to 1. Okay, means that this part must always equal to 1. Okay, so if let's say this number is not equal to 1, so what you have to do is you need to do factorization. Alright, so next, okay, you have to sketch the diagram. Okay, so if you look at the question, okay, you need to sketch direct form 1 and direct form 2. Direct form 1 is also known as non-canonic form. So, alright, so non-canonic means you cannot numerator and denominator not sharing the same delay. Means your numerator will has its own delay. Denominator will has its own delay. Okay, so what we have to do is, okay, as I did mention earlier, in the lecture, numerator part you have to sketch at your right, okay, which is close to your output. Okay, so I'm going to start with our numerator part. So we have a constant symbol and this value is 0.39. Okay, and then we have our first delay. After first delay, we have our second constant, the value is 0.783. And then after second delay, we have our third constant, the value is 0.39. Okay, next, for our denominator part, okay, so again non-canonic, not sharing the same delay. Okay, so for you to sketch the delay, okay, you have to refer to your highest order. For this transfer function, both the highest order is 2, so means you have 2 delays. Okay, so you have 2 delays. Okay, so next 1. Okay, so we have 1. Okay, so after first delay, we have our next constant, which is negative 0.37. So basically, denominator is actually at the reverse direction of numerator. So because of that, we have reverse value. So since if you look here, okay, the value is minus 0.37. So what happened? Instead of we use negative 0.37, now for this value it is positive 0.37, because to show that it is actually at the reverse direction. Okay, next we have our second constant, which is Instead of positive 0.996, now you have 0.196. Okay, let's combine. We combine the component and then connect to our input xn. Okay, done. Okay, so if you look here, okay, at this part, this is always equal to 1. So this part represent this. Okay, so why? Okay, let's see what happen if this value is equal to 1. So what happened to your structure? So in your structure, you must draw your symbol also, and the value of the symbol is 1. You cannot put straight line. If you put straight line, means you don't really understand the definition. This straight line is actually to differentiate, okay, to show that. So this part is your numerator part, and this part is actually your denominator part. So basically, straight line is just to show you the different direction of, the straight line, just to show you it is actually referring to denominator structure. Alright, then for direct form 1. Okay, next we move to second sub question, which is to sketch direct form 2. So direct form 2. Okay, direct form 2 is canonic structure. So because of it is canonic structure, so we are going to combine the delay. Combine delays between numerator and denominator part, means denominator and numerator will share the same delay. So if you look at the given transfer function, the highest order is 2. So for both, for numerator and denominator, so your structure will have 2 delays. 1, 2. Okay, so let's start with numerator part. Okay, so we start with first constant 0.39, and then after first delay we have another constant which is negative 0.783, and then after third delays we have another constant which is positive 0.39. Okay, so we combine them. Okay, done for numerator part. Okay, now we move to denominator part. So for denominator part, okay, use the same delay. Okay, so denominator part at your left. Okay, we start with straight line. Why? Because of our denominator part start with 1. Okay, after first delay, we have our next constant, which is positive 0.37. So why positive 0.37? The value of this delay. Okay, if you look at the transfer function, we have 1 minus 0.37. Okay, why don't we just put negative 0.37? Okay, as you know, denominator part is actually the bottom part of your transfer function. So now we are going to bring it at the same level of your numerator part. Okay, so because of that, we need to differentiate them by using the reverse sign. Okay, that's why if you look at the symbol of the constant, instead of it is like this, now for denominator, the symbol of your constant is actually at the reverse direction. Okay, let's continue. Okay, after second delay, okay, we have another constant, and the value of the constant is negative 0.196. Okay, next we are going to combine the components. Okay, so we combine them, and then we have your Xn. Okay, done. Okay, so basically if you look here, okay, for canonic structure, canonic means we are going to combine the delay, combine or share the delays, means your numerator part and denominator part will share the same delay. Okay, that's all for direct form 2.